Hello everyone, and welcome to another live coding stream. In this live coding stream, we'll be looking at another segmentation problem, where we'll be doing multi-class segmentation on satellite images, drone satellite images. That's not the right word. Drone images on cities. You'll see the dataset soon. But we'll also take a sneak peek on the new tool, or the new interface of the tool rather. So hopefully that will be exciting. But let's jump into it. So, hey everyone, this is well, the first look for the new tool and the interface, how it looks like. So we'll be going through the entire interface and things that changed and everything like that. But before we jump into that and I get to gush about all the changes, let's take a look at the dataset we'll be using first. So as I said, it's a dataset of drone images, and I found it on Papers with Code. It's called Risk-Aware Planning Dataset. And what it does is it contains overhead images, and there's semantic segmentations, so multi-class segmentation. In this case, there's 12 classes, I believe. And it's classes of things like cars, people, roads, of course, buildings, most of the things you'll find in a city. And one thing to note, though, is that the dataset is taken from a simulation. So it's not a real drone, but it's still a pretty interesting dataset. If you follow the link from Papers with Code, you'll come over to here, where you can download it, and shout out to the creators as well. So just download the dataset and it will look something like this. So in here we have shuffled and unshuffled. We'll be using the unshuffled part of the dataset. And they also already split it up into a testing, a training, and a validation dataset. For simplicity, I just took the dataset from the training, and that automatically will be split in PerceptiLabs into training, test, and validation. If you wanted, you could very easily just include the test and the validation dataset in the CSV file if you want it as well, or just the training and validation files, and then leaving test sets out after you deploy the model. And then you can test it outside of the entire training cycle. Anyway, the dataset will look something like this. So we have a bunch of images of cities, well, a city. And can we make this a little bit larger? There we go. And you can see that it's a simulation environment. Sometimes the world just ends, it seems like. But it still provides some interesting, an interesting problem. And you can get some decently taught models on it, which you later on can use for a real use case with a little bit of extra training. All right, so let's jump into the tool. Let's see, here we go. So, one heads up before I start with everything. This is the latest version, which is not yet out, so there may be a few things here and there missing. And I'm also running it locally, because we don't yet have a Docker version of it up and running. So I tested it before, it worked fine, but if it does crash, you'll know why I become a spinning circle. But let's get into it. To explain a little bit what we're looking at, since this overview has changed, the left menu names have changed a bit as well. So this one's now called Overview instead of Model Hub. Instead of just listing the models here, we now also list the datasets. And for every dataset, we list each model under it that belongs to that dataset. So this makes it a lot more data-centric than it was before. Before it was very model-centric. Every model had its own data set. You didn't really know which models had which data sets unless you named them properly. And creating a new model required you to create and load a new data set all over again. Now when you create a project, which essentially is a data set and a model, you get to upload the data set once, and for every subsequent model you're building, just press new model. And here's the data set that I just showed. So you have the images and the masks. This works exactly like before, just looks a little bit nicer. We want this one as a mask, since we want to do multi-class segmentation on it. And we want to make sure to set this to size 224 by 224. And it's always good to normalize it. These ones are already normalized, we don't need to do anything here, and they're already set to 224, 224, so all is good. And then we can create the model. All right. And as soon as this loads, we'll get to see how the, there we go. So everything in here looks a little bit updated as well. A little bit, hopefully, more polished. And the functionality is still the same though. You'll have your normal menus up here with normal components. You can just drag in. You'll have the settings over to the right. Nothing weird or anything has changed there. And the component list, if you want it, is hidden in here. So yeah, except for the design touch up here, not much has actually changed. So we can go ahead and run it straight away. It's I'm gonna try running it first without changing any settings, and we'll see how that goes, and then we'll jump in and play around a little bit with maybe different depths of it, or at the very least changing around to batch normalization, things like that usually helps. So let's set this one to, let's say 5 epochs. Can train 8 each. Since I'm doing multi-class segmentation, I want cross entropy. And then we can train it. Oh, also I haven't shown the coolest part yet. We now have a light and dark theme, which I can very easily swap in between, although you'll see me staying only at dark theme. All right, so we started training, and let's see, we might have to stop a little bit if it's, no, it's going okay speed. All right. So we can see that the predicted image is not very good quite yet, and I'm taking up the target right now so we can compare it with them. But sometime soon we should see the predicted image start getting better and better. We can take a look at the gradients and see. Maybe we got a bad initializations and it died. It didn't. It's still alive, so hopefully it should improve. Can see that the IOU is not very good quite yet. And gonna crash. Let's see. Let's try running on a few less batches, and there we go. See if that helps anything. Did I press to continue from another training? I don't think I did. I did do a run before this, just to try everything out, and as you see, it does get pretty decent at some point. But let's try to start it up again. If we don't get anything here, I'll just do a very quick reboot of the kernel and see if we can't get it running. All right, let's do like this. All right, I am looking in the kernel right now. It seems to be training, or was training there. I'm restarting it real quick. So it might have got an issue just pushing it to the front end together with this with the streaming. Let's start that right back up. All right, there we go. Let's try running it again. At least it doesn't jump us into 75%, so that's a good start. All right, there we go. Let's swap over again to look at the targets at the same time, because as soon as the predictions starts doing more interesting predictions, it'll be fun to compare the target with the prediction, just to see about how close it gets. All right, it's making some new prediction, but it's not looking great yet. Doing something interesting. Looks to be recognizing some areas of the original image. And now it looks like an actual segmentation. Although not as the mask, granted, but they usually start just copying some parts of the input. And you can see the IOU steadily going up. I recently learned that over 0.5 IOU is considered pretty good, at least for binary segmentation, as well as object detection. So let's have that as a goal. I don't know how that scales to multi-class segmentation. 0.5 doesn't sound hugely impressive to me. What it means is that your predicted objects and your actual objects overlap 50%. It's basically what an IOU of 0.5 or higher means, which, and it's not horrible. It means that the predicted is not way out somewhere and nowhere, right? But it's, you can still get quite a bit better overlap than just that. I did a test run before I got to around 0.6 IOU, and at that point the good predictions. So in the test which we get to after this, we can go through the best predictions and the worst predictions, and the best predictions actually look pretty good at that point. I believe I was running it for 10 epochs at that then though, so we're running about half now. So we'll see how close to that we get. Right now it looks to still be doing the thing where it more copies the input than it mirrors the mask. Which is not horrible. I mean, it means that something goes through, right? It's not completely white, as it is usually when you start a segmentation task. But it doesn't quite match what it should yet. All right, just a few more iterations and then we'll be able to jump into test view and see. Compare sample by sample how it performed. After that, I'll try to run it with batch normalization as well and see if we get any increase. I'll try with a batch size of 8 again and see if it works better this time. It might just be my laptop running out of memory, which is strange. When the test run I did, I was recording at the same time, but maybe streaming takes more memory. Anyway, that's not very machine learning related. We can also take a quick look at the gradients to see how they act. And it's not, or it is very common to see this bump at the very start where it first adjusts and then slowly, it doesn't very slowly go down, but goes down to more stable. Either you'll see it jumping and then going down quickly to stable, or a more progressive gradient decrease. As long as it's not 0 or goes towards infinity, it's usually a good signal. But if you also see, you can also sometimes see oscillating or continuous spikes, which could be bad as well. Let's go over to test and try it out. All right. So here we can see the target and predicted. The loss is surprisingly low, considering how much the target and prediction differs. I'm guessing it's because of this big blue area that might do it, and we're probably going to see that in all of these. Yeah. Still, it's not horribly off. It got the blue correct, it's getting the green, which I'm guessing is either, I'm guessing it's water here. And of course this would be just ground or grass or some walkway if they classify it like that, and then the house is in this blue. So even though it's not spot on, it's not horribly off either. And these are the worst cases we're looking at then. Where, again, I mean, it's not spot on, it's missing a big chunk here. But I do get a fair bit of it correct. And this is an IOU of 4.3, so we shouldn't expect it to be too good. But with some longer training, could probably get some pretty good performance out of this. So let's try turning on the batch normalization, and we'll try to do a quick run with batch size 8. Let's do like this real quick. As if we can get the training a little bit faster running. In the next live stream also I'll probably show the new export view. We have a bunch of cool functionality in there, but it's currently being built, so right now it has the functionality, but it looks not as good yet as I would like it. So I'll show that in an upcoming one. But you'll be able to do a bunch of cool things here now, including just starting an app from within PerceptiLabs, rather than having to build something outside of PerceptiLabs to run your model. Oh, it does not like that. All right. The prediction did look very good though. Let me quickly restart it with just batch size of 4 instead, and we can, because that prediction looked very interesting. You can get a quick look of it. All right, there we go. Let's try this. I just realized that my power might not be running as it should. That could be a reason why it's not performing as fast as it should. Well, that's for next time. There we go. Now it's actually turned on. See if that does any difference. All right, so prediction. Actually looking good already after 4%. We should have, okay, from this point on, I'm always gonna start with batch normalization in the unit. It seems to be doing a huge difference every time I try it. You still get these white screens, but in general, it just seems to, yeah, look, our IOU is already up to 0.5. And now things are running faster. I should have looked at the power first if it was on or not. Also, note to self to turn off the power settings on my laptop. Other interesting fact, actual machine learning related, the training is doing fantastic. The validation, not so much. All right, now that things are actually running quick, let me just for fun's sake try to start it with a higher batch size, a bit more epochs, and see if we can get run it to completion and see how it performs then on the test data. All right, here we go. Let's try that. All right, it hasn't crashed yet. That's a good sign. Alright, any guesses as to why the training validation is so good when we turn on batch normalization, but not the validation accuracy? I would be surprised if validation accuracy spikes up this early, but still, it's a little bit too big of a difference. The predicted and the output, and the target, sorry, I mean, do look fairly similar at this point though. Okay, maybe not this one, that's a bad example. All right, let's run the test. See how it performs now with a little bit more epochs and batch normalization, more importantly. Okay. I think it performed better without batch normalization. So batch normalization makes the training look really good, but the testing loss and IOU is horrible compared to how it was before. Alright, anyway, that's everything for the stream today. I hope you guys enjoyed the new interface. I hope you guys enjoyed me crashing a bit and more importantly taking a look at the segmentation from drones. And I think we learned an important lesson with batch normalization. Even though the training looks good, it seems like sometimes it causes validation and test to be way worse than training. It makes it look like. But thank you everyone for joining, and have a great week and a great weekend, and take care everyone.